Uh, this is panel 5, Themes in the Middle East. We have 3 really interesting presentations on pretty good topics this afternoon. We have until 3:15, but I would ask for the presenters to please keep it to 20 minutes or less so that we can have time for a good discussion. If you could all raise your hand or put some text in a chat, then I can call on you. If you'd like to put some lengthy text into the chat, that's great. I will then have you read that. So you might hold off on that and just speak during your question period. All right. Why don't we get started today? Our first presenter is Jeremy Allen, University of Toronto. He will be speaking on the political ecology of famine in 19th century Iran. Jeremy, over to you.
Right away. So, hello everyone, I'm Jeremy, and I'm a grad student at the University of Toronto, graduating from my master's degree. And it's a pleasure to meet you all and be able to present to you my research today, or this afternoon. So the topic I'll be presenting on deals with a famine which took place in Iran in the late 1860s and early 1870s at the turn of the decade. This was a significant famine and led to the deaths of an estimated quarter of the country's population. As you can see in this timeline here, the concentration of this famine coincides with a period of drought, which began as early as 1863 and became more acute from between 1869 and 1871. So there's a lot of information to take in on this timeline. The main trend is that in the years leading up to the famine, there is consistent low rainfall. In 1869, the rain fails completely, gradually returning in 1871 and is fully returned by 1872. And by 1873, William Brittlebank, who's a British traveler traveling through Iran, notes that the famine is completely finished. So the title of this presentation comes actually from a journal, collected a memoir from one Ali Akbar Faiz, a custodian of the mausoleum of Fat Ali Shah in Qom. And he's writing in the winter of 1871, and he's giving his own testimony of the trials and tribulations of life in the city of Qom during this period. So he's writing right at this point right here, right as the famine is climaxing. And he gives the entire chronology of the year. However, he has several very disturbing reports, including reports of cannibalism. One of the most disturbing is he's telling his friends one day gathered outside that his older brother has come across a woman at the tomb of IOWC who was reportedly covered in blood and surrounded by the remains of some 6 children. So this memoir from Ali Akbar Faiz provides a microhistory of this larger disaster which took place during this period. And Faiz's testimony raises several important questions. What are the social effects from this famine? What explains the apparent amnesia which surrounds this famine in the sources? And what was the international response to this famine? Some of these questions have been raised earlier in the other presentations. It's interesting how these topics relate to each other. For those who attended the Indian Ocean Summer School yesterday, this display probably appears familiar to some of you. I wanted to see if the KNMI data we worked with yesterday correlated to the primary sources that I used to build this timeline. And as you can see, there is this correlation. In 1869 and 1870, the rains along the Alborz mountain range in the north are completely disrupted. And this visual on its own lends itself to another important question, which is that precipitation along the Alborz range appears to be the primary indicator of famine or of drought in Iran. This might be of interest to GIS folks in the group. So the question that I mainly wanted to focus on from all these kind of questions that come out of this primary source is what caused the famine? And so to answer this question, my paper has two main components. The first is responding and analyzing, or examining and analyzing the existing literature. And secondly, it's putting forward my own explanation, which redresses the problems with existing hypotheses. So as you can see on this slide here, there are four major hypotheses as to what caused the famine. The first is that drought and some sort of divine intervention which led to this drought is responsible. Contemporary sources such as the New York and London Times are quickly jump to the conclusion that drought was the sole cause of the famine. And in Ali Akbar Feyz's memoirs, he also attributes divine punishment to the drought and the subsequent famine. Of interest here in Persian, Qaḥṭy and Khushk Sali, famine and drought, translated, are synonyms to each other in the dictionary. So this kind of linguistic question is also important. The second explanation is that exports were responsible for the famine. And here there are several testimonies from people in Iran at the time as to exports causing it. For example, in June 17th, 1870, a crowd actually stormed the British trading post in Bushehr, demanding that they release the grain. As you saw 2 slides ago, by 1868, wheat was still being exported from Bushehr all the way through the famine. They were demanding the grain to be released. And similarly, an American missionary in Urmia considered grain shipments from Azerbaijan during this time to be the principal, and I quote, principal cause of the famine. Third hypothesis that is advanced is opium cultivation. As you can see this quote here from G. Lucas, who is the assistant to the political resident of Bushehr. He ascribes opium cultivation, opium production. He views it as replacing foodstuffs, which ultimately left Iran without enough foodstuffs. And finally, the fourth hypothesis that is usually advanced is that price inflation, corruption, speculation, hoarding, all of these things led to people being unable to afford foodstuffs. This explanation is particularly helpful for areas in the country where there is no recorded drought, such as Kurdistan, Loristan, and Gorgan, but there is reports of famine. So I'll go through these quickly. There's a number of problems with all these hypotheses. With drought, there are several reports, such as one from an employee of the Anglo-Persian Telegraph Company in Kermanshah, that there's no drought all along the Zagros range, but as you can see here, there is famine. Similarly, for the hypothesis of exports, in the area of Khorramabad, there is at the time no infrastructure to accommodate the mass export of foodstuffs. However, there are there's evidence that there is up to 75% mortality due to the famine. Similarly, for opium, in the years following the famine, opium production not only recovered, but as you can see here, increased massively, which also causes difficulty for opium production replacing foodstuffs as the main hypothesis. And finally, for price inflation, in 1897-98, there was also a similar price inflation for various foodstuffs, as you can see here on this chart. However, there was no famine then. So that kind of leaves us with, okay, all the seeming hypotheses, all the seeming answers, there's no answer. However, the political residency, again from Boucher in 1897-98, gives us a clue. And he puts the reason for the famine as being, and I quote, an increase in prosperity for the people in Iran. And he actually directly links the two, 71 and 72, 97, 98. So this is also a puzzle for the political residency. So my own hypothesis takes the political residency's diagnosis seriously. My paper answers the question of how the famine occurred by asking how the drought of the late 1860s engendered an economic breakdown in what Amartya Sen calls a crisis of exchange entitlements. So the key to pinpointing where this environmental climactic vulnerability lies is in looking at Iran's structure of what's being called dependent development. So generally speaking, dependent development refers to the gearing of the country's economy to a global economy centered around a metropole rather than organic development according to a country's own productive forces. So in Iran, how does this dependent development structure engender vulnerability? So my paper looks in depth, and I don't have enough time here to go into all the details, looks at this dependent development and breaks it down into internal and external components. So in brief, external components refer to the expansion of European, mainly British and Russian, economic and political influence in the region. Now, the story here is that throughout the 19th century, the increased import into Iran, as with much of the world, of cheaper, high-quality products led to the devastation of the country's cottage industries, such as carpet manufacturing in particular. Now, at the same time, in the 1860s, this coincided with, as is quite well known, the cotton shortage during the American Civil War, 1861 to 65. So this story, 19th century economic story of Iran, from cottage industry to cotton production due to the incentives from the Civil War cotton shortage, and then following the end of the Civil War and the decrease in the price of cotton, eventually to the cultivation of opium. Now, this isn't just an organic kind of accidental story. There's also lots of reports of British diplomats and government officials pressuring the government of Iran to, Qajar government at this time, to export cotton and opium as part of British policy. This leads us to the internal aspects of dependent development. And what I mean here by internal is namely the failure of the Kabirist reforms of the 1850s and 60s. And so the failure of these reforms had two main effects. Firstly, the industrial expansion that Amir Kabir had planned for Iran in order to push back against the encroachment of European imports failed. And secondly, the triumph of a more conservative political establishment after the death of Emir Kabir instituted an austerity regime which saw the privatization of tuyuls, the lands, and also the neglect of qanat infrastructure. You can see here an illustration of the qanat. So the qanat is the main hydrological infrastructure that was used all the way from the Middle Ages into the 19th century. So these aspects of dependent development, as you can see listed here, eroded food security in three main ways. Firstly, the turn to cash crops such as cotton and later opium led to monoculture. And one quote that really comes out of the primary sources is that the peasantry had, quote, nothing but opium by the time the famine arrived. Secondly, the privatization of tuyuls led to the commodification, or read over-commodification of foodstuffs, so that when there was scarcity, the prices had already been competitivized in such a way that it made foodstuffs unaffordable to many. And thirdly, the neglect of qanat infrastructure led to a reliance largely on rain-fed agriculture. And this is very important due to, as we saw earlier, the lack of rainfall. And so I want to conclude just with an excerpt from the final paragraph of this paper. The main takeaway here, I know there's a lot of details and dates and names, but the main takeaway is that with the erosion of these various environmental, cultural safeguards due to the structure of dependent development, when the rains failed in 1869, there was this breakdown of exchange entitlement, which led to mass mortality and famine. And so I'll end it here. Thank you very much for your patience with my microphone, and I look forward to any questions.
York Graduate Center in the US. Scott's going to be talking on tracing the emergence of the world's largest dead zone, plankton, fish, and people in the Gulf of Oman. Scott, over to you.
Great, thank you. Can you hear me okay?
Yes.
Okay, perfect, thank you. Okay, and you can see the screen just fine, right? Okay, so in the spring of 2018, a paper published in the scientific journal Geophysical Research Letters, or GRL, raised alarms about a looming environmental catastrophe. Using underwater drones, scientists from the UK and Oman confirmed that hypoxic or low oxygen conditions encompass a large swath of the Arabian Sea and Gulf of Oman. Media outlets across the world picked up the GRL article and dubbed the Gulf of Oman the world's largest dead zone. The possibility that a stretch of water roughly the size of Florida or Scotland, as many of the articles noted, might be dead, devoid of oxygen and therefore fish, sparked panic conversations online about fisheries, climate, and livelihood in the Northwest Indian Ocean. The Omani government issued an official response to an independent report about the GRL article, calling it exaggerated, inaccurate, and unscientific. In an effort to demonstrate the fertility of the Gulf of Oman, officials cited statistics from Oman's Ministry of Agriculture and Fisheries Wealth, which showed a record-breaking 300,000 tons of fish caught that year. The officials further stated that dead zones are a natural phenomena which occur throughout the world. The contrast between the soberly scientific GRL paper, the sensationalist headlines in the international press, and swift denials by Omani authorities could not be more stark. And while it may seem paradoxical that the officials cited record catch numbers as evidence against the fragility of the Gulf of Oman, something I'll return to later, my hope in this chapter is to contextualize the discourse around the Gulf of Oman's dead zone. Through an exploration of how scientists, media outlets, and government authorities and fishermen understand the dead zone, with an inclusion of historical and ethnographic snippets of what dead zones look like, I aim to provide an outline of the nature and scope of this phenomenon in the Gulf of Oman. I also attempt to trace possible manifestations of a dead zone here in the past, beginning in the late 19th century, as a part of my larger dissertation project exploring colonial governance of fisheries in Oman and the UAE. My goal in the following sections is to serve as a type of translator as precisely the kind of dead zone that currently exists and to outline a possible history of it. Dead zones, or bodies of water that contain dangerously low amounts of dissolved oxygen, are at once a naturally occurring phenomenon and a fairly recent global problem. They're a natural phenomenon because they arise in part due to the consumption of nutrients and oxygen by microorganisms. Where there are more nutrients to consume, the more oxygen is used. They're a recent problem because the levels of nutrients in many bodies of water have skyrocketed, leading to oxygen levels beyond hypoxic or less than normal amounts of oxygen, to anoxic or no oxygen at all. The number and size of dead zones has increased dramatically since about 1950, around the beginning of the Anthropocene. Dead zones have no single cause, but are instead an Ouroboros of causes and effects, such as runoff from raw sewage or agricultural fertilizer, which contains the nutrients nitrogen and phosphorus, the dramatic increase in paved surfaces, which worsen the problem of runoff, diminished salinity due to increased rainfall and runoff, increased stratification of water due to altered salinity, and higher ocean temperatures which make oxygen less soluble, and the proliferation of nutrient-loving microorganisms in the waters. This last problem, blooms of so-called toxic algae, is a close twin with dead zones. Sometimes called red tides, algal blooms are occasionally identified as a cause of dead zones, but are instead trapped in a cause and effect loop with them. For the purposes of this paper, this process is called eutrophication and can be explained fairly simply as follows. The introduction of more nutrients like nitrogen and phosphorus into waterways robs them of oxygen because these nutrients both oxidize and consume oxygen as they themselves oxidize and decay. When a dead zone occurs in the open ocean rather than a bay, lake, or river, it is referred to as an oxygen minimum zone, or OMZ. This is the terminology that the authors of the GRL paper used rather than the headline-grabbing dead zone. OMZs have oxygen concentrations even lower than the level seen in dead zones, about a third less. While the same basic process causes these areas, while the same basic problem causes these areas, the situation is further exacerbated in open oceans because of upwellings from nutrient-rich deep water. Here again, decaying nutrients are the enemy of well-oxygenated water. The size and the scope of the dead zone in the Gulf of Oman is difficult to discern without scientific instruments, but its morbid symptoms have been known to fishermen in residence for decades. The same month that the GRL paper was published, an Omani posted a video on Twitter, viewed several thousand times, showing heaps of dead fish strewn across the beach while people inspect and prod the carcasses with their feet. The user asked what the reason might be for a die-off of this size and where and when this might have occurred, using the hashtag of the Omani Fishermen's Club. Fish kills like this have been somewhat of a common occurrence along the shores of Oman for decades. Some of this is blamed on fishermen dumping bycatch, but the quantity and speciation of fish kills throughout the years suggests that something in the water is to blame. A related morbid symptom is the so-called red tide, often singled out for the rise in fish kills. Red tides occur most commonly in small bays, coves, and inlets around the world and cast a red-brown pall on the water. Sometimes described as toxic algae, red tide in Oman is not the result of algae per se, but instead of a hard-to-classify phytoplankton called Noctiluca silitans. This plankton is a dinoflagellate, whose members can take on either reddish or greenish tints when gathered together in mass, and are known for their ability to phosphoresce. When they proliferate, the daytime appearance of unappealing brown-red or toxic-looking green water often delights beachgoers at night with a bioluminescent spectacle. While indeed beautiful, when quantities large enough to cause a spectacle occur, they eventually die and decay, further robbing oxygen from the water. This is harmful to both fish and humans, which is why they are scientifically known as harmful algal blooms. While these morbid symptoms have been noted throughout the Gulf of Oman, I argue that it's not helpful to think of the dead zone as the size of Florida or Scotland, as the media pieces that followed the GRL piece claimed, because this imposes a terrestrial and therefore flat view of ocean space. Instead, we should consider the ocean as volumetric space. Hypoxic spaces occur primarily at the very depths of the sea, and problem dead zones like the one in the Gulf of Oman, we should imagine as being an enormous bubble expanding and contracting in the middle of the sea that occasionally draws near the surface, but is usually suspended in mid-ocean in the middle of the water column. Scientific instruments can detect traces of this bubble throughout the entirety of the Gulf of Oman, hence claims about its size. But with seasonal changes, currents, temperature fluctuations, and varying levels of harmful plankton, the dead zone bubble is a moving target. But more on that in a moment. In an attempt to trace a history of the dead zone in the Gulf of Oman, I looked for mentions of the aforementioned two morbid symptoms, red tides and fish kills, in historical and archival sources from the late 19th and early 20th century. Both symptoms would have been visible to even a casual observer, and specialists would have certainly taken note. In my research, I have yet to find definitive evidence of either of these symptoms, but have instead found shadows of these phenomena in the form of dinoflagellate-like blooms, oyster die-offs, and abundant fish catches. In the following section, I'll demonstrate how these phenomena might indicate a dead zone in formation in the early 20th century, although I won't be able to prove it in the scope of this paper. Pinpointing the origin of a dead zone without comprehensive instrumental data would be difficult, but it's my hope that we can instead catch glimpses of how a dead zone might be observed before the time of underwater drones and learn something about reconstructing historical data about the ocean through research in the humanities and social sciences. Understandings of red tide as a concept did not permeate into public consciousness in the Anglophone world until the second half of the 20th century, when it was popularized in 1948 by Rachel Carson and Paul Galtzoff, who were employed by the US Fish and Wildlife Service to investigate large streaks of reddish-brown water that coincided with massive fish kills in Florida. Red tides had also been witnessed decades earlier. Most importantly for this study, Mikimoto, the famed Japanese pearl farmer, investigated the presence of what he called akashio, literally meaning red tide, which ruined a crop of his pearl oysters at the turn of the 20th century. Those familiar with the 20th century economic history of crucial Oman might know that Mikimoto's cultured pearls are often blamed for the collapse of the natural pearl market in the Persian Gulf. Crucially, however, the pearl beds of the Gulf also suffered an unexplained natural depletion in the 20th century. A scientific inquiry undertaken by the British government in 1911 blamed predatory fish, parasites, and local Arabs for overfishing. The specialist on loan from Madras wrote that the pearl fishery is suffering from direct and increasingly serious consequence of unrestrained overfishing due to the lack of any restrictions or regulations. And he neglected to note that the market for pearls in the West was at an all-time high. Market demands notwithstanding, I want to consider the possibility that ecological factors in the form of a nascent dead zone also may have contributed to the depletion of these banks in the early 20th century. To this end, the late 19th century notes of Samuel Barrett Miles suggest that mass dinoflagellate blooms may have already been taking place in the Persian Gulf and Gulf of Oman. In his observations on the fisheries of Oman, he notes that during the summer months, the surface of the sea for many miles offshore is covered with floating fish spawn in immense passes of rusty red or yellowish color, and which gives off a disagreeable odor. Miles was no biologist, and to an untrained eye, red tide would have easily been mistaken for a particularly large fish or coral spawn. What leads me to believe that he was observing plankton bloom and not a fish spawn is the following passage in the same text. The luminosity or phosphorescence of the sea observable in these parts is a remarkable sight and presents a magnificent spectacle. In passing near the rocks by night in a boat, the phenomena may be seen to great perfection, the brightness of the phosphorescence lighting up the surrounding objects, each splash of the oars giving a fresh burst of radiance. Similarly, Edgar Boehm's 1904 travelogue, The Persian Gulf and South Sea Isles, offers the following observation of the Gulf. There is at night to be seen sometimes a lot of phosphorescence in the water, and waves of blue flame leap and play about, and the night seems light as day. He added that he had never before seen this curious blue sheen, as if some giant electric light were throwing up rays from beneath the surface. If we take these descriptions at face value, they open the possibility that massive dinoflagellate blooms were already somewhat regular, large, and widespread occurrences in the Gulf of Oman, which, as we have learned, would have had deleterious effects on pearl oysters, as they did with Mikimoto's pearl beds around the same period. The other morbid symptom of dead zones obvious to contemporary residents of the region, fish kills, is also largely absent from the colonial records I've surveyed. Omani fishery scholars have noted that the earliest recorded mass fish kill event in Oman, associated with the red tide, was in 1976. Colonial records before this do not appear to mention instances of fish kills. Instead, almost all records I've reviewed remark on the abundance of fish in the Gulf. As early as the 1880s, British colonial authorities noted with excitement that Muscat is an extraordinarily prolific place for fish, and dozens of files speak to ongoing colonial concern with Oman's oceans and how to govern them. S.B. Miles noted that the coast of Oman is remarkable for the wealth, variety, and strangeness of its marine fauna, and that fish are so abundant that the whole coast of Oman is a continuous series of fishing stations. Lorimer's Gazetteer likewise devotes dozens of pages to Omani fisheries, and hundreds of pages in the British India Office records reveal schemes of how to extract marine wealth from the Gulf of Oman and Persian Gulf. At first glance, these comments about Oman's plentiful supplies of fish seem to work against the idea that the dead zone was beginning to form in Oman at the turn of the 20th century. But if you remember the earlier discussion of the dead zone as a bubble, there's a possibility that these two seemingly contradictory features, abundant fish catches on one hand and a dead zone on the other, are not so incongruous at all. Fish are somewhat famously a moving target. With a few exceptions, they are mobile, itinerant, resilient, and adaptable species. Tuna are known to travel thousands of miles across entire oceans, while other species like sardines and mackerel limit their runs to hundreds of miles along coasts. The point here is that fish are not stationary, but instead highly mobile. David Kirchman has pointed out that dead zones and OMZs are somewhat paradoxically associated with rich fisheries. As dead zones and OMZs emerge, fish end up being pushed to the margins of low oxygen zones, seeking more habitable waters, usually near the surface. The point here is that if we again envision the dead zone as a bubble in the middle of the water column, with fish pushed to the margins of this bubble, dead zones can actually be a boon to some fisheries, certainly so for Oman and the UAE, which historically and contemporarily are artisanal industries manned by small skiffs using hand lines and seine nets to fish surface waters. Again, I pose the question here. Is it possible that the unique abundance of fish in Oman's fisheries in the historical record actually points to a nascent dead zone that was pushing fish away from deoxygenated waters directly into fishermen's nets? Within minutes of the Twitter post that asked about the fish kill on an Omani beach, a founder of the Omani Fishermen's Club brushed it off as a natural phenomena, sometimes caused by the red tide, al-Mad al-Ahmar. There's a tension here between the recognition of the very real threats that this natural phenomenon poses and the reality of consistently good catches that fishermen have witnessed in the last several years. Just this month, a member of Oman's governing body shared an image of a map purporting to show the size and extent of the dead zone, saying roughly, "It isn't true that the map which is circulating shows the size of the dead zone in the Oman Sea, as it includes the coasts of Sharqiya, Muscat, and the Batna, and indicates that these areas are dead and there's no life in them. This contradicts reality, which is that the coasts of these three governorates are the best places for landing fish in the region." This post was also shared widely among the Omani Fishermen's Club, and again speaks to a seemingly contradictory view among those individuals whose livelihood depends on the health of Omani waters. Rather than viewing these online sentiments as avoidance of a looming problem, however, my argument is that the pragmatic views of Omani fishermen are a kind of synthesis between the apparently opposing viewpoints of the scientists and government officials laid out at the beginning of this chapter. Omani fishers, perhaps more than any other stakeholder, have the most interest in preserving the health of fish stocks in the region. Their recognition of both the reality and persistence of fish kills caused by red tides and their assertion that catches are plentiful despite reports of a dead zone is a kind of mediating view that avoids the cold rationality of science and the sensational alarmism of popular media. This position reflects a possible reality of the situation, that despite occasional massive fish kills washing ashore, fish escaping the dead zone might sometimes flee directly into their nets. And while a problem certainly exists somewhere in the Oman Sea, it is by no means a dead space in the sense that it is completely devoid of oxygen and therefore fish. The sheer abundance of fish in the Gulf of Oman, noted by colonial observers and contemporary officials alike, belies a larger problem. But that problem still seems to be somewhere on the horizon instead of immediately apparent. Fishers, scientists, government authorities, and researchers alike should all be concerned with the future implications of dead zones. Natural forces like the monsoon, paired with further despoliation and warming of the ocean by humans, together presents a problem. not that fish will immediately disappear or that the ocean will suddenly be dead. Instead, these shifts have the potential to cause cracks in the base of the food chain, which may be imperceptible to us now and appear as aberrations in the same way that mysterious die-offs of pearls or pearl oysters and bioluminescence were outside the understanding of historical figures. Analyzing the problems of the present requires an attentive, holistic, and detailed ethnographic eye, and we can only hope that we might leave traces of possible answers to our collective problems for future researchers to discover somewhere between the lines. Thank you.
Thank you, Steve.